All right, round two. This is the same exact thing as day one. It's just more practice. So you have a rule for products, you have a rule for quotients. They're basically just following formulas. They are shortcuts for finding derivatives, which you will spend half of your life doing in calculus. So to have a little bit of background is going to be hopefully very helpful. This one is going to be quotient because it's a fraction. Here's a fraction. Here's a fraction. Lots of practice with that. This one, I could put a big old dot between the 5x squared and the cosine. That's a product. This one, I've got a little teeny dot. I'm going to make it bigger in between these two bad boys, so that's a product. This is going to be a quotient, and this is going to be a quotient. So a little bit heavier on the quotient rule, which is fine because yesterday's had a little bit more of the product rule. And again, watch the making of video day one key and also watch the video for the notes if you need to. You can find the links on the weekly plan, which you already know because you're already watching this video. Okay, so I don't care. Let's try number one. So this is going to be me differentiate. So that's just the verb to say find the derivative of. Since this is a quotient, I'll be using this rule. I'm going to have the top, and I'm going to, which they're calling v, and the bottom, which they're calling u, and then I'm just going to follow my rule. So on the bottom, I'm supposed to take the current bottom, which is x cubed. No, x squared. Can't see, old folks. And then square it, because that's what it says in the rule. I'm going to zoom in a little bit more for me, not you. Sorry. Then on the top, I'm going to repeat the bottom, and you can see it's not prime, so I'm just going to write the bottom as is. That's the u. Then I'm supposed to multiply it by the derivative of the top. Now that looks like it's going to be tricky, but no, because remember the derivative of e to the x just stays e to the x. So having 3 times that derivative just is going to give us 3e to the x. So weirdly, e to the x is its own derivative. Kind of weird. Then the rule says to subtract, and I like to put a big old bracket so I remember to distribute it if that's an issue. Now I'm supposed to take the top without the derivative because there's no prime, so the top is 3e to the x. Then I'm supposed to multiply it by the derivative of the bottom. So the derivative of the bottom, it's currently x squared, so think about that. I need to drop the power down and multiply it by the coefficient, and then reduce the power by 1. So it goes from being a second power to a first power. Then my job is to simplify, put stuff together, just kind of make it all nice and neat. X squared squared becomes x to the fourth. Here I have x squared times 3e to the x. Here I'm going to move the x part out in front. 2x, actually that would be a 6 because I have a 3 there and the 2, so I'll have 6x and then e to the x. Now keep in mind, you can cancel out anything that all 3 parts have. This has an e to the x, as does this, but this one doesn't. You can see 3's come out of these two, but not this one. But everybody has at least one x to give up. So when you go to write your final answer, it does have to be in simplified form because we're in big people math. So if I take out an x from each corner, this will become 1x. And I'll probably put the 3 in front because I like to be mathy. So the number goes in front, and then I'll have 1x left, e to the x. Here I took out an x, so I'll have minus 6 e to the x. On the bottom, I took out an x, so I'll have x to the third. So that's probably the best way you should write that for accuracy's sake. All right, let's do another quotient that's not a polynomial. I don't want to do that one. That's going to be way too much fun for you. Let's try this one, I guess. So I'm going to think about this as the u and think about this as the v. So when I follow my formula, the derivative of x is going to be on the bottom. I'm going to take the bottom and square it, but I'm not going to really square that out. Then I'm going to take the bottom times the derivative of the top. So think about the top. This is x to the first power. So this term, the 1 will multiply by the 4, and the x will lose the only power it had. So I get just a 4. And minus 5 is a constant, so its derivative is 0. So I just have the 4. Minus, and then whatever I get over here. Now I'm supposed to take the top, which is 4x minus 5, and multiply it by the derivative of the bottom. So the 2 is going to go away because it's a constant. Here, the 1 power multiplies by the 3, and then the x loses its power, so it's gone. So now it's time to clean up the top. So my derivative we'll have, and I'm going to distribute my 4, 12x plus 8. Inside here, distributing the 3, I'd have 12x minus 15, but then there's a negative out in front that's going to distribute to both of those parts. So I would have minus 12x, and then minus that negative becomes a positive. I never distribute the bottom because there's no reason to. So these actually cancel, and my final derivative answer in simplified form is going to be 8 plus 15, so 23, over 3x plus 2 quantity squared. So fun. Let's do one of these two product rules. Let's do this one. So product rule, that's this guy right up here. So I'm going to need to think of one part as the f and one part as the g. Then to do my derivative, I'm supposed to take f, which is the first part with no changes, times the derivative of g. So keep in mind, the derivative of cosine is negative sine. The derivative of sine is regular cosine. So in this case, since I had a cosine, its derivative will be negative sine. Then I'm supposed to add, I'm just following my formula, the second part with no changes. So the second part would be cosine x times the derivative of the first part. So here, the derivative of the first part, the 2 would drop down, multiply by the 5, and then the x loses 1 power. So it drops down to a power of 1 rather than a power of 2. And now it's just time to algebra and make this pretty. So the negative would come out in front with the number. I'd have x squared sine x. Here I like to put the number out in front with the x's, and then any weird stuff like cosines, ln x's, e to the x's go after that. So there, my friends, is my answer. So I did like half your homework for you. You're welcome. So, okay, not quite half. Try these others, just following the pattern. Again, you can look at the examples in the notes from day 1 or from today. And that, my friends, is quite possibly the last thing you're going to need to do on a piece of work page for me. We have a little quizzes next week to make sure you know what you're doing. But you have just finished your last worksheet for this year in high school. Makes me sad. Probably makes you super happy. See you soon. Bye.